All right, welcome to The Explainer. Today we are diving headfirst into something called educational data mining, or EDM for short. Now, this is a field with a huge promise. It could totally change how we learn. But, and this is a big but, it also brings up some really tough questions we have to tackle. I mean, just imagine this for a second. What if you had a personal tutor who could adapt to your every single need? One that knows exactly when you're starting to zone out or when a concept just isn't clicking. And then it serves up the perfect problem to give you that amazing aha moment. Sounds like something out of a movie, right? Well, it's not. This is the real driving ambition behind the tech we're going to break down today. So let's talk about this dream, this idea of personalized learning. It's something educators have been chasing for decades. And you know what? Educational data mining? Well, that's the engine that's trying to finally make it happen. Okay, so take a look at this. This feedback loop is really the core of how it all works. You see, it all starts with the student, right? They're using some online tool, interacting with a course. Every single thing they do creates data. That data gets scooped up and analyzed. That's the mining part. The insights from that, what the system discovers, get sent right back to the teacher or the course designer. And they can use that to make the system even better. So it's this constant cycle of learning and getting better for both the student and the system itself. Right. So at the end of the day, what EDM is really trying to do is take these huge, kind of overwhelming piles of raw data and turn them into something useful, something meaningful, and, this is the key word here, actionable. Information that people can actually do something with. And we're not just talking about for the students. This is for teachers, for the people who build the courses, even for school administrators. Okay. So to really get how this all works at a massive scale, we need to do the opposite. Let's zoom way in. Let's focus on just one student and the trail of data they leave behind. You know, every single time a student clicks on something or answers a question in an online learning tool, they're leaving behind a trace. It's called a digital footprint. And when you think about platforms like an intelligent tutoring system, or even common ones like Moodle or Canvas, well, they aren't just places to get information. They are actively, constantly gathering data. And this footprint is made of what researchers call fine-grained data. And that's a perfect description because we're talking about way more than just whether you got an answer right or wrong. We're talking about how many times did you try a quiz? How long did you actually spend on a problem? Did you ask for a hint? Did you rewatch a video? What order did you do things in? Even what you say in a discussion forum, all of it. Every little piece tells a part of the story of how you're learning. But, and here's our first big reality check, the data we get is almost never perfect. In a perfect world, yeah, you'd have this complete grid showing every student and every problem they ever tried. But the real world? The data is what we call sparse. It's full of holes. For example, look at this system called SpellBee. Researchers there found they had data for less than 1% of all the possible student and problem combinations. And not only was it sparse, it was also biased. Why? Because human tutors were picking the words to give to students, and they were often just going with their gut. So the big question is, how do you take this messy, incomplete digital footprint and actually turn it into something useful? Well, that's where the mining part of the name comes in. And this isn't just random. It's a really structured process. First, you've got to select the right data to even look at. Then comes the really hard part, pre-processing. Honestly, this is where most of the work happens. It's all about cleaning up that messy, real-world data, figuring out what to do with all the missing pieces. And it's only after you've transformed it into a nice, clean format that you can finally let the algorithms loose to find those hidden patterns. Which leads us to probably the biggest question of all. How can a computer system really know what a student actually knows? I mean, really? Answering that gets to a very specific and super important goal in this whole field. The key concept here is something called latent knowledge estimation. And that word latent just means hidden. You can't literally look inside a student's brain and see their knowledge, right? It's unobservable. All you can see is their performance, how they answer questions. So latent knowledge estimation is basically the art and science of trying to model that hidden knowledge, that true mastery, by looking at the patterns in their performance over time. A classic way to do this uses an algorithm called Bayesian knowledge tracing, or BKT. Now, instead of just saying a student knows something yes or no, BKT thinks in probabilities. It calculates the probability that a student knows a skill, and it updates that probability after every single thing they do. But here's the clever part. It's smart enough to know that a student who doesn't know the material might get an answer right just by guessing. And it also knows that a student who does know the material can still make a simple mistake, a slip. By factoring in both the chance of a guess and the chance of a slip, it gets a way more realistic picture of what a student actually knows.
And it's not just about figuring out what a student knows right now. Prediction is another huge goal. Can we forecast what a student's final grade will be? Or maybe, more importantly, can we identify who's at risk of dropping out and do something about it? Then there's relationship mining. This is all about finding hidden connections. Like, do students who watch one particular video almost always nail the quiz that follows? Finding patterns like that is incredibly valuable.
Okay, so we've looked at the individual student's footprint and some of the tech used to analyze it. Now, let's zoom all the way back out. What happens when you apply these ideas not to one student, but to millions? The scale here is just mind-boggling. I mean, look at this. The Junyi Academy dataset has over 16 million exercise logs from over 72,000 students, and that's just one dataset. Others, like EdNet, have hundreds of millions of interactions. This is the big data that makes this entire field possible. And when you have that much data to work with, the predictive power can be absolutely incredible. For example, one study looked at university student records and found that some algorithms could predict future academic performance with over 98% accuracy. Just stop and think about that. Imagine being able to identify a struggling student with that level of certainty. The potential for helping them early on is just massive. Naturally, this explosion of data has fueled a huge boom in research. This table here kind of gives you a snapshot of how the field is now breaking up into all these different specialties. You've got researchers who only focus on making better educational recommendations. Others are dedicated entirely to knowledge tracing. It's what you see when a field really starts to mature and people dive deep into specific problems. Okay, but with all of this incredible power and all this potential comes some very, very significant risks. We've talked about the promise. Now, we absolutely have to talk about the peril. This quote here, this is so important to understanding the problem. It says that data doesn't just reveal or reflect the world. It orders and constructs the world. It's a powerful idea. It forces us to get rid of this notion that data and algorithms are just neutral tools. They aren't just watching what happens, they are actively shaping what happens next. And that brings us to one of the biggest ethical minefields. Here's the dilemma. These predictive models often get more accurate if you feed them demographic data, things like race or family income. But what happens if the data you're training it on already reflects generations of societal bias? Well, the algorithm learns those biases. It might correctly predict that a student from a low-income background is more likely to struggle, but in doing so, it can lock them into that path, creating a self-fulfilling prophecy and making the original inequality even worse. And there's another risk, one that's a little more subtle. What happens to a student's own sense of who they are, their own freedom, when a system is constantly pushing them down a path it has predicted is best for them? One researcher gave this a pretty chilling name: constructed subjectivity. Think about it. The system learns who it thinks you are, and then it just keeps feeding you things that reinforce that identity. It could end up limiting a student's ability to discover something new about themselves, to change, to grow in unexpected ways. And believe it or not, the ethical stakes are about to get even higher. Because the very idea of what a student is, from a data perspective, is changing. In the past, the data was pretty simple, just final grades, stuff like that. Right now, it's all about those super detailed click streams we talked about. But the future? The future is what's called multimodal data. We're talking about systems that analyze a student's speech, their gestures, even their facial expressions, to see if they're engaged or confused. We're shifting from modeling a simple user to modeling a complex, emotional, social human being. And all of this, it all leads to one pretty stark realization. As education becomes more and more data-driven, more automated, the power to define what good learning or success even looks like, that power shifts to the people who are writing the code. And so that leaves us with maybe the most important question of all. As we build this future, who gets to write the code? And whose values, whose vision of education are they building into these systems that will shape the next generation?